The purpose of this activity is to explore and explain relative density. You will be able to compare the relative density of items to each other. Density is a measurement. It describes how much matter is contained in a certain space. All materials have a set density measurement. In some materials, the particles that make up the substance are closely and tightly packed together. These items have a high density, or they are said to be more dense. Other materials are comprised of particles that are spread out. These materials are said to have a low density or to be less dense. Relative density means that you are comparing two items. You're looking to see when they're mixed together if they sink, float, or stay at the same level. We often use water to help us understand and explain density. Pure water has a density of 1 gram per cubic centimeter. Items that have a density measurement that's lower than 1 are less dense than water. They will float when placed in water. Items whose densities are greater than 1 will sink when placed in water. They are more dense. We will be looking at the relative densities of water, oil, glass, rock, copper, wood, cardboard, plastic, steel, and salt. Let's first start with oil. We will add the oil to the water. If the oil is more dense than the water, the oil will sink and stay below the water. If the oil is more dense, the water will float on the oil. If the oil is less dense than the water, then the oil will float on top of the water. What do you think will happen when we mix oil and water? Which item will be more dense? Pay close attention to what the oil is doing as we add it to the container. Now, as I drop it in, gravity is going to pull it down rather swiftly. But once it combines with the water, does it stay below the water or does it float on top of the water? The oil is on top of the water. It is floating. So does that mean the oil is more dense or less dense? You can also look at it the other way. Is water more dense or less dense than oil? The water sank when we mixed them. The next item we'll use is glass. What do you think the glass marble will do when we drop it in the jar with the oil and the water? Will the marble sink or float in the oil? Will the marble sink or float in the water? The marble sank through the oil and through the water. The oil is floating on top of the marble. The water is floating on top of the marble. Now you can compare the relative density of these three items. The top layer would be the least dense. The bottom would be the most dense. So out of oil, water, and glass, which item is the most dense? Out of oil, water, and glass, which item is the least dense? Now let's look at rock. What do you think this pebble will do when we drop it in the jar? Again, you can compare the relative density of the items. How would you say the density of the rock is compared to the oil? Is the rock more or less dense than the oil? Compare the rock and the water. Is the rock more or less dense than the water? Now, if we look at the glass and the rock, it would be hard to say which of the two is more dense. But we can say what both of their densities are compared to the water. Next, we'll try copper. What do you think copper will do when placed in water? Did the penny sink or float in the oil? Does that mean it is more or less dense than the oil? Did the penny sink or float in the water? Does that mean it is more or less dense than the water? Our next item we're going to compare is cardboard. What do you think will happen when I put the cardboard in the jar? Do you think it'll sink or float? Now the other items, when I dropped them in, gravity pulled them down with enough force that they went below the surface and then either continued to sink or floated back to the top. This item has a wide surface, and I'm going to have to assist it to make sure that it breaks the surface of both items and then either continues on its way or floats to the top. So I'm going to drop it in the jar and then poke it. What can you tell me about the cardboard? Did it sink or float in the oil? Did it sink or float in the water? Let's compare the density of the cardboard to the oil. Is the cardboard more dense than the oil or less dense? It sank in the oil. Is the cardboard more dense or less dense than the water? Well, the cardboard floated on the water. Let's compare steel and the density of steel to the density of oil and water. What did the steel paperclip do when dropped in the jar? Is the paperclip more dense or less dense than the oil? Is the paperclip more dense or less dense than the water? Now compare the paperclip to the cardboard that's sitting right there. Is the paperclip that sank and is sitting below the water? Is it more or less dense than the cardboard that's floating on top? You can rank these 4 items, steel, water, cardboard, and oil, by their relative densities. Which of the items is the most dense? Which item is the next most dense? Which item comes next? Finally, which item out of steel, water, cardboard, and oil is the least dense? Let's compare plastic. This is a section of a plastic fork. Again, I will have to assist this item to make sure it breaks the surface so we can see accurately if it sinks or floats. I did not have to assist. Look at the plastic. Is it more dense or less dense than the oil? Is it more dense or less dense than the water? Now, let's look at wood. Different types of wood have different densities. This is pine. What is the pine doing in the oil? Is it floating or sinking? I'm going to move the plastic out of the way. Will the wood continue to sink in the water? It did not. There is the wood. Is the wood more dense or less dense than the water? Is the wood more dense or less dense than the oil? Let's look back at our glass marble. Is the marble more or less dense than the wood? Well, the wood is floating on top of the water. The marble sank. How about plastic and glass? Which material is more dense? Well, the marble sank in water while the plastic floated. Now we're going to look at cork. Cork is a natural material made from trees. What do you think cork will do when we drop it in oil and water? Well, here is the cork. Did the cork sink or float? The cork is floating on top of the oil. That means that the cork is also floating on top of the water. So let's compare the densities of cork, oil, and water. Would you say that the cork is the most dense or the least dense of the three items? Would you say that water is the most dense or the least dense of the items? Well, the most dense item is going to be the one that sank. If we're looking at water, oil, and cork, which item sank? The final item we're going to look at is salt. Today we're going to use very coarse salt so that it's easier for you to see in the jar. What do you think salt will do when it is placed in oil and water? Will salt sink or float? There's the salt. Is the salt more dense than water? It sank all the way to the bottom. Is it more dense than oil? Well, it sank through the oil. Let's compare the salt with the plastic. Which item is more dense? The least dense item will be floating above the more dense item. You can now sort all of those items and arrange them according to their density. Out of all the items, which one is the least dense? Which one has a similar density to other items? How many items are more dense than water? How many items were less dense than water? To see how many items were more dense, you would look at which items sank in the water. To see which items are less dense than water, you would see how many of the items floated in the water. That is relative density.